Good day, my dear learner, and all other colleague teachers watching this video. I beg of you to subscribe to this YouTube channel for more videos. Still on circle theorem, we would like to look at same chord or arc subtending angles at the center and the circumference of a circle, and this would be the part 2. If you have not watched the part 1, please go and watch it. The property says that the angle formed at the center of a circle is twice the size of the angle at the circumference subtended by the same chord or arc. Now, ED is taken as our chord. So, all that this theory is saying is that this ED, line ED, which is our chord, subtend two angles, one at the center and one at the circumference. So, if you want to get the angle at the center, if you know the angle at the circumference, just multiply the angle at the circumference by 2 to give you the one at the center. And if you know the one at the center but you don't know the one at the circumference, just divide the one at the center by 2 or just multiply it by half to get the angle at the circumference. And this was explained by moving angle EJD, which is the angle at the circumference, and placing it on angle EID, which is the angle at the center. And we could all observe that angle EJD fits only half of the angle at the center, EID. And from this, two equations evolved. That angle EID is equal to 2 times angle EJD. And the vice versa is that if you need angle EJD, just find half of angle EID, and that is what you see on the screen, the point 2. Now, when you draw a line from point J to the center I, it divides triangle EJD into 3 triangles. So we have one of the triangles here, that is EIJ. We have another triangle JID, and we have one triangle at the base, that is EID. Now, let's look at something. I am moving some of the angles. You just observe critically. You see that I am moving angle JEI, and look at how beautiful Jojoba is doing. Good. We could see that the angle at the base of triangle EIJ fits equally in the angle EJI, meaning that the bases are equal because all these 3 triangles are isosceles, meaning they have 2 of their sides being equal. and those two sides that are equal are all radii. Now, we continue to move the other one. Look at it, angle GDI. Wow, that is GeoGebra. Now, it also fits equally in the angle IJD, meaning these two angles are also equal. They are base angles and they are equal. Today, we want to relate angles at the center to the angles at the circumference from the part 1 of this video. Now, we see that these two angles, when they are added, it gives us angle EJD. And that is what you see on the screen. Angle EJD is equal to angle JEI plus angle JDI. So when we multiply their sum by 2, it should give us the angle at the center here when line ED is taken as the chord. So we get angle EID equals 2 times the sum of these angles, and that is angle JEI plus angle JDI, all multiplied by 2. That's why you see the 2 in front here. Let me take those angles back to their position. Now, we are going to take JE as our chord. When JE is taken as the chord, it would subtend 2 angles. The angle at the center here, that is JIE, and the angle at the circumference, that is JDE. This means that angle JIE is equal to summing these 2 angles and multiply their sum by 2. So we get angle JIE is equal to 2 times bracket open angle JDI plus angle IDE bracket close, and that is what you see here. Left with the last. When JD is also taken as a chord, it would subtend angle JID at the center and angle JED at the circumference. So this means that when we add these 2 angles and multiply them by 2, we would get the angle at the center, that is JID. So that is what you see on the screen. Angle JID is equal to 2 times bracket open angle JEI plus angle IED bracket close. Now, from point 4 to point 6 are the angles at the center. When all these angles are added, they would give us the sum of 360 degrees. And that is what you see, point 7. Angle EID plus angle JIE plus angle JID is equal to 360 degrees. So these are some of the things you should know about this theorem, and I will try to explain everything under this theorem before we move on to another theorem, because if you understand this theorem very well, it would help you to solve many questions and it would save you a lot of time. Please subscribe to this YouTube channel for me. Now let's move on and solve questions so that it would help us to understand this theorem very well. Question 1. In the diagram, O is the center of the circle. The points A, B, and C are on the circumference of the circle. Angles CAO and AOB are 32 degrees and 140 degrees respectively. Calculate I angle OBC, II angle COB. And this is a WASI question. July 2005 question 12B. To solve this, we must start from the known to unknown. And what is known here? We know two of the angles. And from that, we could solve the question. So, starting from the center, I can divide 140 degrees by 2 to get the angle at the circumference. So from the property, we write that angle ACB, which is the angle at the circumference, is equal to half of angle AOB, which is the angle at the center. So by substitution, we get angle ACB is equal to half times 140 degrees. Please, this is the same as dividing 140 degrees by 2. So don't worry about the half times 140 degrees. And that would give us 70 degrees, which means the angle at the circumference ACB is 70 degrees. Now, that is written on the screen. From there, the property also makes it known to us that angle OAC is equal to angle OCA. Since the triangle formed is an isosceles, so the base angles are the same, and hence if here is 32 degrees, it means the other angle is also 32 degrees. Therefore, that is also written on the screen. Now, if we know that the whole of angle ACB is 70 degrees and part of it is 32 degrees, then it is easy to find the other part, and that is done by subtracting 32 degrees from 70 degrees. So we can say that angle OCB B is equal to 70 degrees minus 32 degrees. So that we get angle OCB to be 38 degrees. And that is also shown on the screen. Now, the triangle COB is also an isosceles triangle, and hence its bases should be the same in value, meaning that if angle OCB is 38 degrees, then OBC should also be 38 degrees. So from the property, we can say that those two angles, each of them is 38 degrees as shown on the screen. And that is also written in the diagram, 38 degrees. Now, it is easy to answer question I, which is OBC. So we have it written, and therefore we only say that angle OBC is equal to 38 degrees. I hope this is simple and easy to understand. Let's move on to the second question, which is angle COB. Angle COB. Okay, that is the center angle for the triangle COB. Now, we know that their bases, each of the bases is 38 degrees. So we just multiply 38 degrees by 2, or we just add 38 to the other 38. And because triangle, the interior angles sum up to 180 degrees, we subtract from 180 degrees. So we can say that angle COB is equal to 180 degrees minus 2 times 38 degrees. 2 is multiplying 38 degrees because 38 degrees appears twice. That's why. So that 2 times 38 degrees would give us 76 degrees, and we subtract from 180 degrees. And therefore, the answer is angle COB equals 104 degrees. So the two questions have been answered, and I hope it's very simple. Please subscribe to my YouTube channel for more videos. Question 2. In the diagram, O is the center of the circle. The point A, B, and C are on the circumference of the circle. Find the measure of angle CBO. So we are going to find angle CBO, which is the S degrees here. Let's solve it together. From the property, we know that when we divide the angle at the center by 2, or we multiply it by half, we would get the angle at the circumference. So angle ACB is equal to half times angle AOB. And by substitution, we get angle CB is equal to 1 over 2 times 120 degrees. And that would give us 60 degrees. So angle ACB is equal to 60 degrees. Let's write that in the diagram. Good. Now that it is written, from the video, we know that when we add angles CAO and OBC, they should give us the angle at the circumference. So we add them, and that is angle ACB is equal to angle CAO plus angle CBO. And now from our calculation, you already know angle ACB, which is 60 degrees. That's the angle at the circumference. So we write that 60 degrees is equal to, then angle CAO. CAO is x minus 10, all into bracket, degrees. So that is what you see here, plus angle x degrees. And that angle x degrees is for angle CBO, plus x degrees, and x degrees is for angle CBO. So that is already written. We just expand and we get 60 degrees is equal to x degrees minus 10 degrees plus x degrees. We group like terms. We want the negative 10 degrees to be at where the 60 degrees is. So we add its additive inverse, that is positive 10, to both sides of the equation. So we have 60 degrees plus 10 degrees, and then s degrees minus 10 degrees plus 10 degrees plus s degrees. So this negative 10 plus 10 degrees would be 0, and 60 plus 10 degrees would be 70 degrees. Then x degrees plus s degrees would be 2 degrees. So we have 70 degrees equals 2x degrees. Now we divide both sides by 2. So 70 degrees over 2 is equal to 2x degrees over 2. So that 2 goes into 70 degrees, 35, and 2 goes into 2x degrees. The 2 would cancel the 2 here. So 2 goes into 2s degrees, s degrees. And then we have s degrees is equal to 35 degrees. So question 2 is solved. Now let us look at the assignment. That is the question on the screen. Pause the video, solve it, and you compare your answer with that of mine. The answer is angle PQO is equal to 65 degrees. If you had different answer, then rethink and do it again. Well done, but I beg of you to subscribe to this channel. We shall again look at the part 3 of this same theory. May God be with you till we meet again. Bye.